This video is on graphing systems of equations in slope-intercept form. You already know what slope-intercept form is. Slope-intercept form, as a reminder, is y equals mx plus b, where m is your slope and b is your y-intercept. What you don't know yet is what systems of equations are. A systems of equation is two equations like this that relate to each other, but you, at this moment in time, don't exactly know why or how the two equations relate. What we're going to be doing in this video is graphing these two equations on a graph that looks like this, and then we'll be solving the system by looking for the intersection point. Take a moment to pause the video and jot down all 4 steps into your notebook. Now that you've got the notes jotted down in your notebook, these are the steps to graphing a system of equations. So step 1, you first have to have both equations in slope-intercept form. This is going to be key. Remember, that's y equals mx plus b, again, where m is the slope and b is the y-intercept. Then you need to graph both of the equations on the same piece of graph paper, like on the intro slide, where you could see 2 lines that intersected. What you're going to be looking for is the intersection point. This is going to be the solution to the system. So to write your answer is going to look like an ordered pair. Then to check your answers, you can plug the ordered pair or the solution into both equations. In order for the ordered pair to be a solution, it has to work for both equations. Okay, here is our first example. The system is y equals 3x minus 2 and y equals x. So the first thing I need to do is I need to graph both of these equations on this graph, this little sheet of graph paper here. Before I do that, I need to make sure they're both in slope-intercept form, which they are because they're both solved for y. So if y is by itself, I'm good to go. All right, what I need to do next now is I need to write my slope and my y-intercept. So my slope in the first equation is 3. So the slope, if you remember, is the number in front of x. I'm going to write that as an ordered pair. I'm going to write that as a fraction, as 3 over 1. My y-intercept is the number after my x, or the coefficient, the number that's all by itself. So in this case, it's negative 2. So I'm going to go to my graph, and I'm going to plot, or I'm going to graph this equation, starting at negative 2, which is my y-intercept. And I'm going to use the ordered pair, or the slope, 3 over 1 to go up 3 and right 1. All right, up 3 and right 1. All right, at this point, you need to grab a straight edge and connect these points with a ruler. Now, because of this tool, this technology tool that I'm using, a ruler does not work for me. So you are going to do a better job than I am, and that's the best that I can do right now. I'm going to label this equation. You can also see everything on my graph is going to be color-coded, so feel free to color-code your homework as well. So my red line is y equals 3x minus 2. Now what I need to do is I need to go and I need to graph y equals x. So I'm going to write down my slope and my y-intercept. All right, my slope. So my slope is the number or the coefficient of x. Well, there is no number in front of x, but there is 1x. So my slope is 1. I'm going to write that as a fraction, 1 over 1. My y-intercept is the number after x, or the number that's just a constant. In this case, there isn't another number, so that means it's 0. So I'm going to graph starting at 0. That's my y-intercept. And I'm going to use my slope, 1 over 1, to get some points on my line. So if I go up 1 and right 1, you can see I've got an intersection point right there. I'm going to continue to plot a few more points. I can also go down 1 and left 1 to get some points to the left of the y-intercept. Now, again, you're going to grab a straight edge. I'm not able to use one on this technology, so I'm going to do the best that I can. Hopefully, seeing that this is my intersection point. That's where both lines have a dot or a point. So I'm going to label the green line y equals x. All right, my answer to the system is going to be the ordered pair where they intersect. So my answer is 1, 1. So it's going to be this ordered pair right here. That's my answer. Now, to check my answer, I can substitute 1, 1, 1 for x and 1 for y into both equations to see if it really truly is the solution to both equations. So I'm going to plug 1, 1 into y equals 3x minus 2. So I'm going to plug 1 in for y and 1 in for x. So I get 1 equals 3 minus 2, which is a true story because 1 does equal 3 minus 2, which is 1. Now what this tells me is that this ordered pair here is a solution to the first equation. And I can prove that because there's my work. Now I need to check to see if it is a solution to the second equation. So I'm going to plug 1, 1 into my second equation. So I'm going to plug 1 in for y and 1 in for x. Okay, 1 equals 1. That was pretty simple. So what I know here is that this work in black pen says that I just proved my answer algebraically. So I know that 1, 1 is the solution to the system because I can see it on a graph, and when I plug in my ordered pair into both equations, they work. Ladies and gentlemen, this is our second system that we're going to solve by graphing. Okay, if you look at this system, what should appear different to you is that these equations are not solved for y, which means they're not in slope-intercept form. That's the first thing that we need to do, is put both of these equations in slope-intercept form. So I'm going to rewrite the first equation, and I'm going to solve for y. So I'm going to subtract 3x from both sides, and I'm going to get negative y equals negative 3x plus 1. Now, if you notice, y is still not by itself because it's got this negative. So if you remember from when we were doing a lot of work with algebra, we said that if there's a negative in front of a variable, it's really negative 1. So what I need to do is I need to divide everything by negative 1 to get y by itself. So I'm going to get y equals 3x plus negative 1. So this is my first equation. All right. Right next to that, I'm going to write my slope and my y-intercept. So my slope, I'm going to squeeze it in here, is 3 over 1, and my y-intercept is negative 1. All right, now I'm going to take my next equation, which is 4x plus 2y equals 8. And I'm going to solve this equation for y. So I'm going to subtract 4x on both sides, and I'll get 2y equals negative 4x plus 8. That's supposed to be an x there. Divide everything by 2. And I am going to get y equals negative 2x plus 4. So that's my equation in slope-intercept form. Now I'm going to write my m and my b. So my m is, my slope is negative 2 over 1, and my b is 4. Okay, so what I'm going to do now is I'm going to go back to my graph, and I'm going to plot the first ordered pair, or the first equation, excuse me. So in my first equation, my y-intercept was negative 1, and my slope was 3. So I'm going to find negative 1 on my graph, which is right here, and I'm going to use my slope of 3 to go up 3 and right 1. Up 3 and right 1. I can also go down 3 and left 1. Okay, this is where you're going to grab a ruler and you're going to use a straight line. You can see that's not very good there, to draw in your straight edge, or to draw in your line with a straight edge. Then you're going to label your line, y equals 3x minus 1. Okay, now I'm going to grab my orange pen, and let's see here, my slope is negative 2, and my y-intercept is 4. So my y-intercept is 4. I'm going to plot that point here. And because it's negative 2, that means I'm going to go down 2 and right 1. You can already see my intersection point there. I'm going to do a couple more points. So you can see if I had done a better job of drawing that blue line, it would go straight through that point where my orange line lines up on top of my blue line. And then my equation is y equals negative 2x plus 4. So I'm going to label that. Now, I'm not done, of course, until I write my ordered pair. So my ordered pair is this intersection point right here. It is 1, 2. So that, ladies and gentlemen, is how you solve a system by graphing.